So I don't think I'll forget, but like today's lecture won't take the full time. But like at the end of lecture, what I want to do is show you some apples on the iPad. Apples. Apps, oh my gosh. Applications on the iPad. So, all right. Today we're going to finish Unit 1, last part in Unit 1. So there's this thing called the law of periodicity, and more kind of recently I've thought of if something's periodic, it comes back around. And I really think like days of the week come back around. Like so for instance, Sunday nights you do certain things, okay? Mondays are all kind of similar. Tuesdays, you might have classes, you may not. Okay, Wednesdays, Thursdays, Fridays are awesome, right? And then Saturdays, you catch your breath. And then Sundays, you gear up for Monday usually. And then you do it all over again, okay? So basically, you do 1 week, 7 days, and then you do it over again, okay? And then you do it over again, etc. It's periodic. So what this ends up being, do you see where all Sundays are kind of like each other? You know, all Mondays are like each other. All Fridays, yay, kind of have a similar, okay? Saturdays, kind of similar. So the thing I'm looking over here at the periodic table, actually, that is arranged so that it's just like a calendar, okay? If you look at a periodic table, you recognize, we've talked about the whole numbers as the atomic number. It's the number of protons in the nucleus of each atom. And it kind of goes, 1, 2, then it goes 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, okay, to 36, okay? And then it goes to the next row, okay? And the cool things are rows, that's fine, we're going to call those periods. But the coolest thing is this, we're going to call those groups, okay? And so when Dmitri Mendeleev, who is kind of attributed to organizing the periodic, the elements, the way we have them in the periodic table, when he organized the periodic table, he kind of wrapped back around and made sure that things that were similar kind of lined up, like your days of the week lined up, okay? So we call it a group, okay? This vertical column is called a group, and that's really where it's happening. So this chapter, the part of this chapter, I think it's still chapter 2, but this part 8, is just to kind of look at the periodic table. And I already talked about periodicity, and so like actually, vertically speaking, elements have very similar properties. There are different ways to chunk up a periodic table. Okay, one way to chunk it up is to look for the JAG. I keep calling it the JAG. One of these days I'm probably going to switch what the name is, but it just like it's like stair steps. And you may or may not remember that what that does is separate the non-metals. Now there aren't very many non-metals, are there, from the metals. And we're going to talk more about the lanthanide and actinide series coming up, but they actually are metals also. Okay, so we don't have very many non-metals. So one of the things is you need to kind of orient yourself to the periodic table. So things along the JAG are called metalloids. Okay, so kind of those yellow boxes now are along the JAG. It means that they're kind of have properties of both being a metal and a non-metal. I kind of tease because depending upon which chemist you ask and what kind of mood they're in, they might kind of break it up a little bit different, but they're all kind of along the JAG. I've got for instance, 6 highlighted there. You may look on the internet and how many or what are the metalloids, you might come up with 7 or 5, I don't know. Okay. So these are groups. Okay, these are like days of the week. Okay, they have similar properties, and we're kind of counting on that. Okay. You kind of see 2 designations. So right now it's 10. Okay, now it's 11 1B, 12 2B, 13 3A, 14 4A. I prefer the AB. That's kind of the old-timey sort of things. as the name of the group. Okay, so what I was saying was, up here, this is the name of the group. So anytime they ask you in homework or in a test, what is that group name, that's what you're going to look for, is the top of the column, the designation. Like I said, I'm kind of old school, and I didn't learn it with the 1 through 18. I learned it kind of with the A's and the B's. Okay, so kind of you'll hear me call out the name that way, the group name. But I think your textbook prefers the 1 through 18, which probably is, they're both good. They both have advantages. But those are called groups. So yet another way to chunk up the periodic table. We talked about the JAG. Now this is not the JAG. Another way to chunk up the periodic table is to focus on the group A elements and the group B elements. Okay? The group A elements are called main group elements, but I guess if you're going with the convention 1 through 18, you don't have the A or the B designation. The main group elements are the first two groups. You skip these, what we call the transition metals. We're going to come to that, but you skip the indented part, you got 2 groups, you skip the indented part, and then you have 6 groups. Okay, those are main group elements. And like I said, sometimes you'll hear me go back in time, and their main group elements are also group A elements. Not group E, group A. Group A elements. Makes sense? So that can be helpful. The transition elements, sometimes called the transition metals. The transition elements are that indented part, okay? Transition elements or transition metals. Notice they're all group B. All right. Did I skip one? Guess not. Okay. Oh, and by the way, if you're counting groups, there actually are 10 across here, and it won't be clear till the end of the Gen Chem 1 that we talk about finding homes for electrons, and some of you guys might remember we put 10 electrons in the D-type subshell. That's actually where that 10 kind of comes from. All right. So then going across would be like a week, right? Week 1, week 2, week 3. Those are called periods. So not on this slide, but I kind of wanted to go ahead and give you a copy of, let you see what's going to be on your test next Thursday. Oh, no, really. On your test, you're going to get one of these, so I'll go ahead and give you one. If you want to mark it up for the one you're supposed to memorize, it's the same as you have in other documents. So I had them sitting around, so I'm like, oh, I should get those out. This is exactly what you're going to have on your test. So I passed this out because, so can you see over there on the left-hand column, or on the left where it says hydrogen, lithium, sodium, potassium, rubidium, cesium, francium? That number there on the far left is the period number. So that's like which week it is. So there's all sorts of, like your homework, you're going to have to say, you know, give me a 2A element, a 2A group that is in period number 6. Period number 6. So that's just barium, right? Yeah. So that's the period number. I think your textbook has them too. Does it have it just next to the, has the period number? Okay, good. Okay, those are periods. Gotta love them. Okay. Well, 2 periods that I didn't go through a minute ago maybe are down here. Well, they're not really periods in of themselves. Let's look at these stragglers down here. And let's see, 10, 14. Actually, there are 14 here. So like an F-type subshell, we can accommodate 14 electrons. That's kind of where that comes from. So actually, if you look at here with lanthanum, atomic number 57. So notice that on a normal periodic table, it goes to next atomic number 72. So the missing elements are right down here. So it goes 57, 58, all the way to 71, then it goes back to 72. So these actually are kind of inserted there, right? So in other words, put another way, and I'm going to have to pull up the one I just gave you. Lanthanum is in period 6. Lanthanum is in period 6. The lanthanide series elements are also in period 6. Okay. The actinide series elements down here. Where did it go? Okay, the actinide series begins with thorium, and these I kind of forget what the name, the symbol and names are. Okay, but actinium, element 89, and then we go to 90, 91, etc. 103, back to 104. Okay, so they are in period 7. Okay, and collectively, those two series down there, we're going to call those F block elements, actually, coming up at some point. Those elements are called the inner transition elements. Inner transition metals and transition elements. Okay. All right. So it's all about the group, right? There are some groups that have special names that you'll need to know. So for instance, 1A, group 1A are called the alkali metals. Now notice hydrogen I don't have highlighted here as being an alkali metal. Somebody recently pointed out that actually the periodic table I gave you, hydrogen is on there twice. Hydrogen is over here, 1A, and it's also over here, 7A. Because sometimes hydrogen behaves like a 1A what, metal? Sometimes it behaves like a 7A non-metal. All right. So know this name. This name is alkali metals, my bad. You already got that. 2A, know that name too, they're the alkaline earth metals. And I might have told you this before, but I hate things that start with the same letter, so of course Al got that both going on. So the way I remember it is alkaline earth. You have to go over, because it's like that, it's more wordy. Alkali metals, alkaline earth metals is 2A. And then we skip clear over to 7A. And 7A are called the halogens. And then last but not least, everybody loves the 8A elements. They actually have 3 names, and they're all listed up there. You know how back in the surf system, the nobility was kind of rare? Okay, so they're actually called noble gases because they're kind of rare, and they're called rare gases because they're rare. And they're also called inert gases because they're inert. Inert means that, like, if you have an inert medicine in your inert ingredient in your medicine, it's not going to react, going to do anything. And so that's actually the way they are. They don't like to play with anybody else. So 8A are the inert gases, noble gases, rare gases. So here again is the same slide that I showed you earlier. You just need to be able to match up the symbol of the element with the name of the element. And that's not just for your Unit 1 test, that's for the whole semester. And we need to be able to kind of rock and roll. Like if you see Na, you need to recognize that's sodium. If I say mercury, you need to know that that's Hg. Okay? I'll show you. Yeah, go ahead.
So you need to know these for the whole semester.
For the whole semester.
So you're not going to be adding additional. Okay.
Yeah, that's a good point. Nope. You need to know for the whole semester. And some of you already know, but before, like I said, we'll kind of wrap up lecture here in a minute, and then I'm going to show you some apps on my iPad. And actually, some of these apps, you can get them on anything. Even some apps you can get on the computer. So one of my apps that I like is called Chemistry Mahjong. And if you're familiar with Mahjong, you have to match up the same ones, and then you go away, the tile game. So basically the way this goes, and I'll show you, is you match up the symbol with the name, and they go away. So it's kind of clever. It's the little things, right? Okay, so we chunked up the periodic table, kind of understand the periodic table. So we talked back earlier that we can use properties as characteristics of matter, okay? There are chemical properties and physical properties to be measured. Physical property, no chemical reaction needs to occur. So actually these are all physical properties of matter. With regard to both electrical and thermal conductivity, in general, if I was to ask people, you probably say metals are better at conducting electricity and conducting heat, and they are. It's just a general physical property of them. With regard to being shiny, that's what lustrous means. Metals, again, win, okay? Your magnesium, some of it really shined yesterday, okay? With regard to being malleable, and actually these all three, these malleable and ductility, malleability and ductility kind of go together. Malleable just means can you pound it into a sheet, and ductile or ductility means can you pull it into like a wire. So of course metals are great at that. So down here at the bottom, metals tend to be lustrous, malleable, and ductile. But non-metals, not so much. So, of course, there's the whole physical phase issue, like those elements. Are they gases, are they liquids, or are they solids? And so this slide kind of emphasizes that. We only have 2 liquids, but it's kind of fun to think about that. If we were on a different planet, okay, with different temperatures and pressures, actually that might be different, okay? So we have a handful of gases. I do believe it's exhaustive. I think the gases, there are only those that are listed there. The liquids, only those are listed there. Everything else, a solid, under normal atmospheric temperatures and pressures. So I have some pictures here. If you're a visual person, you can almost kind of pick out the metals, the lustrous ones, okay? Then kind of an assortment of non-metals. Now sometimes students are like, they don't want to use the periodic table to their best interest. So for instance, I'm like lead. Lead, is it a metal or not a metal? Well, find it on the periodic table, find the JAG, and convince yourself what it is, okay? Sometimes we think sodium. Well, sodium is like table salt. Table salt's not a metal. But wait a minute. Find sodium on the periodic table. It is clearly a metal. That's one of the things we're going to talk about on Monday is compounds. And it's interesting when elements are not in their elemental form, but when they join to something else to form a compound, all bets are off. Okay? So that's that. Some other pictures. Okay, so here's your assignment. We'll take a quick look at that, and then I'll kind of switch gears so I can show you what I want to show you. So these are what these look like. They're really not too bad. Yep, I even made a hints thing there. This is what they look like. So 51, you won't need your calculator for this. I kind of remember the designation, the group 14. If you look, and actually what you're going to be getting on Thursday has both the 14 designation and the 4A. B, an element that's similar and one that's different than sulfur, you get a pick. It's all kind of fun reading your answers. Numbers are for C, an alkaline metal, that's one of the things you're supposed to commit to memory. It's 1A. Halogen is 7A. So now on to 52. I kind of need to say a little bit about that. It's kind of similar to question 51. Now C and D is different though. So for C, it actually talks about ions. C and D both talk about ions. And some of you have already had this and remember it. Some of you had it and forgot it. Okay. Some of you haven't had it recently. But E raised to the 2 minus, that just means that it's negative 2 charged. We talked about anions, it's an anion, okay? And so it's picked up 2 electrons, and one of the things we're gonna talk about is that actually, things that pick up 2 electrons are 6A nonmetals, okay, 6A nonmetals. So oxygen, sulfur, selenium, maybe tellurium, we're kind of getting into the metalloids, pick up 2 electrons. Okay. And you wouldn't necessarily know that, we haven't covered that yet, but we're gonna. And then the other thing, the next one for D, it says, all right, I have an element that's got a +3 charge. That means it's kicked off 3 electrons. And things that kick off 3 electrons are 3A. So actually, 3A metals, excuse me. So starting with aluminum, gallium, indium, thallium, and atomic number 113. Which, how old is that periodic table anyway? That's what I want to know. Like, I think some of those are filled in, maybe not, maybe it's not as old as I think. But anyway, those elements kick off their 3 electrons to get, remember, that kind of rare gas configuration. So you wouldn't necessarily know that yet, but I'm telling you in my hints. Okay? Any questions?